Okay, now the next part of the question, how high up does the rod go before it stops? We're going to argue that the kinetic energy of the rod is conserved, so by the time that the rod rises, it changes into potential energy, right? It has a certain kinetic energy, and then by the time that the rod is at a certain angle, it has a certain potential energy, right? What matters is where's the center of mass of the rod. If it's a uniform rod, it's at its center, right? How high does the center of mass rise? Okay, well, if this distance is L over 2, this distance is L over 2, and then this distance here is going to be L over 2 times cosine theta, right? So what's the height going to be? The height to which it rises. The height is going to be L over 2 minus L over 2 cosine theta. Okay? So the potential energy that the rod is going to gain as a result of rising, the potential energy, final, is equal to mgh. So mg times L over 2, we can factor out L over 2, 1 minus cosine theta. Okay? So the height is equal to the L over 2, 1 minus cosine theta. You set that equal to the original kinetic energy if we assume that the pivot point has no friction. So initial kinetic energy is half I omega final squared, right? That's equal to mg L over 2, 1 minus cosine theta. Moment of inertia is the moment of inertia about the pivot point, which is 1/3 ml squared. Moment of inertia 1/3 m L squared. Omega final is going to be the answer that we got here, 1.29537. 1.29537 squared mg L over 2, 1 minus cosine theta. Okay, and then the m cancels the m, L cancels one of the L's. So 2 cancels the 2. So what's left here? We have one of the L's remaining. Okay, we have a 1.29537 squared. We got the 3's remaining, right? Because the 2's canceled, but the 3 didn't cancel. And then we have one of the L's remaining, and then the G goes down to the bottom. So that's 9.8. And that's equal to 1 minus cosine theta. Right? And then L was the length of the rod, which was 4 meters. Okay? So let's calculate all of this. The thing comes out to be 0.228297. And then cosine comes over to the other side. So subtract 1 from this. 1 minus the answer. 0.7717. So cosine theta is 0.7717. Now take the cosine inverse of that. Cosine inverse of the answer, 39.49 degrees. 39.49 degrees. That is the answer. So the rod, after being hit by the sphere, goes up to 39.49 degrees, which looks kind of like this. Huh? Not even 45 degrees. It's a little less than 45. Okay, so this is a really good example of a problem where you have to analyze whether angular momentum, kinetic energy, or linear momentum is conserved. And then once you decide, then you set up the equations. The angular momentum one is pretty tricky in this one, to set up the angular momentum equation. So it's a really good example of this situation. And then once you get the final angular velocity of the rod, then you can calculate to what height the rod rises. Thank you very much.